Picture this, a machine so powerful, it doesn't just crunch numbers. It rewrites the rules of reality itself. A device that doesn't just solve problems, but might be pulling answers from places we can't even imagine. Google's quantum computer, a marvel of human ingenuity, has done something unthinkable. It's performed calculations so fast and so precise that some of the sharpest minds in physics are whispering a possibility that sounds like it was ripped from a sci-fi blockbuster. What if this machine isn't just computing in our world? What if it's reaching out, tapping into other universes, pulling data from realities we can't see, hear, or touch? The implications are staggering, thrilling, and more than a little terrifying. If true, humanity might have just cracked open a door to the multiverse without a clue what's waiting on the other side. Let's start with the basics, because to wrap your head around this, you need to know what a quantum computer even is. Regular computers, the ones we use every day for everything from scrolling social media to launching rockets, rely on bits, those trusty ones and zeros that form the backbone of digital life. But quantum computers, they laugh in the face of binary. They operate on qubits, which, thanks to a mind-bending principle called superposition, can be a 1, a 0, or both at the same time. Imagine spinning a coin in the air, and instead of landing heads or tails, it's somehow both at once, exploring every possible outcome simultaneously. That's the kind of power we're talking about. Add in another quantum quirk called entanglement, where two particles become so linked that messing with one instantly affects the other, even if it's halfway across the galaxy, and you've got a recipe for something that doesn't just compute. It rewrites what we think is possible. Back in 2019, Google's quantum chip, codenamed Sycamore, sent shockwaves through the scientific world. It solved a problem in 200 seconds that would have taken the fastest supercomputer on Earth 10,000 years to crack. They called it quantum supremacy, a term that sounds like it belongs in a superhero movie, but actually means a quantum machine outdid every classical computer in a specific task. It was a flex of cosmic proportions. Since then, the race has been on, not just to make quantum computers faster, but to make them stable. Qubits are finicky, prone to losing their quantum magic if the environment isn't just right. We're talking ultra-cold temperatures, vacuum-sealed chambers, and shielding from even the tiniest vibrations. It's like trying to balance a house of cards in a windstorm while riding a unicycle. But the payoff? A future where quantum machines don't just do parlor tricks. They solve problems that could change everything. Now here's where things get wild. The conversation around quantum computing has taken a turn into territory that sounds less like science and more like something you'd hear around a campfire at midnight. Some physicists are starting to wonder if these machines are doing more than just crunching numbers in our reality. The theory, and brace yourself for this one, is that quantum computers might be interacting with parallel universes. Yes, you heard that right. The multiverse, that staple of comic books and late-night dorm room debates, might not just be a cool idea anymore. It might be real, and we might already be poking at it with our fancy new tech. The idea comes from the same quantum principles that make these computers so powerful. Superposition means a qubit can hold multiple states at once. Scale that up, and you've got the possibility of entire universes existing in parallel, each one a different version of reality where every choice, every event, branches off into its own timeline. Maybe there's a universe where you chose a different career, or where dinosaurs never went extinct, or where gravity works backward. The multiverse theory suggests these realities are stacked side by side, invisible to us, but just as real. And here's the kicker. Some scientists think quantum computers, with their ability to process countless possibilities at once, might be able to peek into these other realities, or even pull information from them. This isn't just idle speculation. It's grounded in the weirdness of quantum mechanics, where particles can exist in multiple states and entangled particles can share information instantly across vast distances. If a quantum computer can manipulate these strange properties, could it, theoretically, access data from a parallel universe? Could it run calculations that aren't just happening here, but across multiple versions of reality? The thought is equal parts exhilarating and unsettling. It's like realizing your new smartphone might accidentally dial an alien civilization. Let's dive deeper into why this idea is gaining traction. When Google's Sycamore chip smashed that computational record, it didn't just solve a math problem, it produced results that were almost too perfect, too fast. Some researchers noticed anomalies in the data, tiny glitches or patterns that didn't quite add up under our current understanding of physics. These weren't errors in the usual sense. They were more like whispers of something else, something that didn't fit neatly into our world's rulebook. A few bold physicists started to wonder, what if these anomalies aren't random noise? What if they're signals, fragments of data bleeding through from another reality? It's like tuning a radio and picking up a faint broadcast from a station you didn't know existed. This brings us to the big question. Could quantum computers act like cosmic radios, picking up transmissions from other universes? The idea sounds insane, but let's break it down. Quantum calculations involve manipulating qubits in ways that explore every possible outcome at once. If the multiverse is real, each of those outcomes might correspond to a different reality. So when a quantum computer runs a calculation, it could, in theory, be processing data not just from our universe, but from countless others. The anomalies researchers are seeing, those unexpected patterns, might be the first hints of this. They could be mathematical echoes, like ripples in a pond, caused by a stone thrown in another dimension. Now imagine what this could mean. If we could decode these signals, we might access knowledge from universes where science, technology, or even society evolved differently. Picture a reality where cancer was cured decades ago, or where clean energy powers entire planets. A quantum computer tapping into that kind of data could revolutionize medicine, engineering, even philosophy. It's like finding a cosmic library with the answers to every question we've ever asked, and a few we haven't thought of yet. But here's the flip side. What if we're not the only ones listening? What if other realities have their own quantum machines and they're picking up our signals too? Suddenly, we're not just explorers, we're part of a multidimensional conversation, and we don't know who's on the other end. This idea isn't without its skeptics, and for good reason. Science demands evidence, not just cool stories. Right now, there's no definitive proof that quantum computers are communicating with other universes. The anomalies could be explained by errors, limitations in our technology, or gaps in our understanding of quantum mechanics. But the fact that serious scientists are even entertaining the possibility says something about how far we've come. We're no longer just building faster computers, we're probing the very fabric of reality, asking questions that blur the line between physics and metaphysics. Let's talk about the implications, because they're massive. If quantum computers can interact with parallel realities, the practical applications could be staggering. In medicine, for example, we could access treatments from universes where diseases we struggle with have already been eradicated. Imagine downloading a cure for Alzheimer's from a reality where it's as treatable as a common cold. In energy, we might discover technologies from worlds that ditched fossil fuels centuries ago. Think solar panels that harness 90% of the sun's energy, or fusion reactors that fit in your garage. Even artificial intelligence could leap forward, trained on insights from countless versions of reality, making it smarter, more creative, and maybe even a little too independent for comfort. But with great power comes great responsibility, and this is where things get murky. If we can pull knowledge from other universes, who controls it? Governments? Corporations? The scientist in the lab who happens to hit the right button? The potential for misuse is enormous. Imagine a nation using quantum tech to borrow military strategies from a reality where they won a war we lost. Or a company monopolizing a cure from another universe, selling it for billions while people die waiting. The ethical dilemmas are dizzying. We'd need global agreements, ironclad regulations, and a whole lot of humility to ensure this power doesn't spiral out of control. And then there's the darker side, the stuff that keeps you up at night. What if the door to the multiverse swings both ways? If we can peek into other realities, could something peek back? Maybe it's not friendly. Maybe it's not even human. The idea of accidentally opening a channel to a universe with hostile intelligence is the kind of thing that makes your skin crawl. Even if the other side isn't malevolent, the act of connecting could disrupt both realities. Physics as we know it is delicate. Messing with the fabric of one universe might ripple into others, causing chaos we can't predict. It's like throwing a rock into a still pond and realizing the ripples could flood an entirely different lake. This isn't just a tech problem, it's a philosophical one. If the multiverse is real, what does that mean for our sense of identity? Are there infinite versions of you out there, living every possible life you could have chosen? If so, what makes this version of you special? The psychological impact could be profound. Some people might find it liberating, a reminder that every choice creates a new reality. Others might spiral into existential dread, wondering if their life is just one insignificant thread in an infinite tapestry. Religions, too, would have to grapple with this. Many already speak of other realms or higher planes, Hinduism's infinite universes, Buddhism's parallel worlds, even Christianity's spiritual dimensions. If quantum computers prove these ideas have a scientific basis, it could spark a cultural earthquake, blending faith and physics in ways we've never seen. Let's zoom out for a moment and think about what this means for humanity as a whole. We've always been explorers, driven by curiosity to map new lands, conquer the skies, and probe the stars. Quantum computing could be the next frontier, not just in space, but in reality itself. But are we ready? Our history is littered with examples of technology outpacing our wisdom. Nuclear weapons, social media, you name it. If quantum computers open a window to the multiverse, we'll need to grow up fast. We'll need to ask not just what we can do, but what we should do. Because once you open a door like that, there's no telling what might walk through or what we might accidentally let out. Now let's get practical for a second. How would we even know if a quantum computer is pulling data from another universe? The short answer is we wouldn't. Not yet. Scientists would need to identify patterns in the data that can't be explained by our current laws of physics. Maybe it's a sequence that repeats with impossible precision, or a result that defies probability in a way that screams, "This isn't from here." But spotting those patterns is only step one. To confirm they're from another reality, we'd need a way to test and replicate the findings, and right now, we're nowhere near that. Quantum computers are still in their infancy, like the first clunky computers of the 1940s. We're playing with fire before we fully understand how to light a match. Still, the fact that we're even having this conversation is a sign of how fast things are moving. Just a few decades ago, the idea of a computer outperforming the human brain was laughable. Now we're talking about machines that might chat with other dimensions. It's a reminder that science doesn't just answer questions, it raises new ones, often scarier than the ones we started with. And that's what makes this so thrilling. We're standing on the edge of something huge, something that could redefine not just technology, but our entire understanding of existence. Let's talk about the cultural ripple effects, because they're just as big as the scientific ones. If quantum computers confirm the multiverse, it'll change how we tell stories, make art, even think about ourselves. Filmmakers will have a field day, churning out blockbusters about scientists battling interdimensional invaders or lovers reuniting across parallel worlds. Writers will pen novels exploring what it means to be human when there are infinite versions of you out there. Musicians might compose songs inspired by the hum of quantum signals, a cosmic symphony of alternate realities. But it's not all rosy. The internet already spreads misinformation faster than wildfire. What happens when someone claims they've got proof of a signal from another universe? Conspiracy theories will explode, and separating fact from fiction will get even harder. Then there's the spiritual angle, which is impossible to ignore. For centuries, humans have believed in realms beyond our own, whether it's the afterlife, the spirit world, or the infinite layers of reality described in ancient texts. Quantum computing could give those beliefs a scientific backbone, turning metaphors into math. Imagine a world where a priest quotes quantum entanglement in a sermon or a meditation app, guides you to align your chakras with the multiverse. It sounds far-fetched, but so did the idea of a global network connecting every human just a generation ago. This could be a beautiful fusion of science and soul, or it could spark conflict as old beliefs clash with new truths. The military implications are where things get really chilling. Governments aren't exactly known for sitting on their hands when new tech comes along, and quantum computing is no exception. Imagine a world power using a quantum computer to pull strategies from a reality where they won a war we lost, or an AI trained on multi-dimensional data capable of predicting every possible outcome of a battle in real time. It's not just about winning wars, it's about rewriting the rules of power itself. If one nation gets a head start, the global balance could tip overnight. And if multiple nations start racing to weaponize the multiverse, we could be looking at a new kind of arms race, one where the stakes aren't just territory or resources, but reality itself. What about time? Quantum mechanics already messes with our understanding of it. Particles can exist in multiple states, which some physicists think could extend to multiple points in time. If a quantum computer can process data from different timelines, we might glimpse the past or future. Imagine predicting natural disasters with pinpoint accuracy, or solving historical mysteries by pulling data from a reality where they were never mysteries at all. But messing with time comes with risks. What if seeing the future changes how we act, creating paradoxes that unravel the fabric of our reality? The butterfly effect is scary enough in one universe. Imagine it across infinite ones. Let's not forget the environmental angle. Climate change is one of the biggest challenges we face, and classical computers are already struggling to model the complex systems involved: weather patterns, ecosystems, carbon cycles. Quantum computers could handle that data with ease, and if they're pulling insights from other realities, we might discover solutions we'd never dream of. Maybe there's a universe where humanity cracked fusion energy a century ago, or where forests were engineered to absorb carbon at 10 times the rate. Borrowing those ideas could be a game changer, but only if we use them wisely. The temptation to exploit other realities for quick fixes could backfire, creating new problems we can't even imagine. The conversation around quantum computing isn't just about tech. It's about who we are as a species. Our curiosity has always driven us forward, from the wheel to the moon landing. But it's also gotten us into trouble, from pollution to nuclear standoffs. Quantum computers could be our greatest leap yet, but they could also be our biggest stumble. The question isn't just what these machines can do, it's whether we're ready for the answers they might give us. If they're talking to other universes, what are those universes saying? And are we prepared to listen? This brings us to the heart of the matter: restraint. Just because we can build a machine that might pierce the veil of reality doesn't mean we should rush to do it. Science thrives on caution as much as it does on boldness. We need to test, verify, and double-check every step. We need to ask the hard questions, not just how, but why. If we're opening a door to the multiverse, we'd better make sure we know what's on the other side before we step through. Because once we do, there's no going back. The beauty of this moment is that it's not just scientists in lab coats driving the conversation. It's spilling into the mainstream, sparking debates in living rooms, coffee shops, and yes, podcasts. It's reminding us that science isn't just about facts, it's about wonder, about pushing the boundaries of what we believe is possible. Whether quantum computers are truly communicating with other universes or not, the fact that we're asking the question is a testament to how far we've come. We're not just building machines, we're chasing truths, wrestling with mysteries, and daring to dream bigger than ever before. But dreams can become nightmares if we're not careful. The multiverse might hold answers to our greatest challenges, but it could also unleash questions we're not ready to face. The anomalies in quantum data might be noise, or they might be signals from realities we can't comprehend. Either way, we're at a crossroads. Do we charge forward, fueled by curiosity and ambition? Or do we pause, take a breath, and make sure we're ready for whatever comes next? The choice is ours, but the consequences might echo across more than one universe.